Good evening, friend. Today we are learning the special purpose diode, in which the first diode is Zener diode. There are two sub types in Zener diode, the avalanche breakdown diode and a Zener diode. Then we will see the light emitting diode and photodiode. Let us see the first category, Zener diode. What is Zener diode? Zener diode is a PN junction diode and it is highly doped PN junction, specially designed to operate in the reverse breakdown region. Doping level is precisely controlled to get the desired breakdown voltage. When the reverse voltage is applied across the diode and when it reaches to the Zener voltage, also called knee voltage, the junction breaks down and the current flows in the reverse direction. This effect is known as Zener effect, and that's why the name of the diode. It works as a normal diode when operated in forward bias. There are two types of breakdown mechanism in Zener diode. One is avalanche breakdown and another is Zener breakdown. The avalanche breakdown normally works at higher reverse breakdown voltage and the Zener breakdown normally works at lower breakdown voltage, normally less than 6 volt. The breakdown voltage of the Zener greater than or equal to 6 volt, normally considered as avalanche Zener diode, and less than 6 volt Zener voltage diodes are normally recognized as the Zener diodes. Let us see what is the avalanche breakdown in Zener diode. Normally, avalanche breakdown diodes, Zener diodes, those are having low doping level. Avalanche breakdown occurs in the normal diode and Zener diodes at high reverse voltage, whereas avalanche breakdown is dangerous and damaging for conventional normal rectifier diodes, and therefore it is not recommended to operate the conventional rectifier diodes in the breakdown region. Whereas Zener diodes, they are specially developed to operate in reverse breakdown region, and therefore they can be operated in breakdown region at high voltage also. High reverse voltage applied across the device more than the breakdown voltage makes the free minority electron gain sufficient energy and accelerate at high velocities. When these minority electrons or minority charge electrons, those are accelerated and they cross the p-n junction barrier, they strike the immobile ion. When they collides with the immobile ions in the depletion region, they supply the energy to the immobile ions. So the electrons are getting shifted, valence electrons of those ions getting shifted to conduction band. So striking or collision gives rise to one electrons collides with the immobile ion, gives rise to or liberates one additional electron. So one becomes two. Again they are accelerated with high velocity. They strike again with the another atom, immobile atom, liberates additional 2 electrons. So 2 becomes 4, 4 becomes 8. Likewise, this process is a multiplication process called as avalanche multiplication. And suddenly, the large current is flowing through the Zener diode, whereas voltage across the Zener diode maintained constant, that is the breakdown voltage. The Zener diode is specially designed to sustain the breakdown voltage. Another type of breakdown is a Zener breakdown. See here. Normally, Zener breakdown occurs at less than 6 volt. For getting the lower breakdown voltage, these diodes are highly doped. High doping gives rise to lower breakdown voltage. This breakdown, Zener breakdown, is normally due to potential barriers electrical field energy. High doping leads to thinner depletion barrier, which leads to higher electric field intensity as shown by the formula E is equal to V by L. So larger the doping level, smaller will be the depletion region. When the applied reverse bias reaches closer to the Zener voltage, the electrical field becomes sufficient to snatch out the additional electron from the valence band of the immobile ions in the depletion region. And therefore, large number of charge carriers are available for conduction. And therefore, suddenly the reverse current start flowing in the large amount when the voltage crosses the Zener diode. Due to high doping level, more and more valence electrons gains the sufficient energy at the lower breakdown voltage. This energy is gained from the strong electrical field of the depletion region, thus results in the large breakdown current. So one thing to be noted, when the large breakdown current flows, this current is only limited by the external limiting resistance, and that's why the current limiting resistance is always required. In a reverse breakdown region, Zener breakdown region, the small increase in voltage results in rapid increase in the electric current. Let us see the characteristics shown here. We will come back to the characteristic again. What are the differences between avalanche breakdown and Zener breakdown? Zener effect is dominant in voltage up to 5.6 volts and avalanche effect is more dominant above 5.6 volt. They both are the similar effect. The difference is Zener effect is a quantum phenomena and avalanche effect is a colliding moment of the electrons in the valence band. Avalanche effect also allows larger current through the diode than the Zener breakdown would allow. Let us see the symbol of the Zener diode. Here you will see the Zener diode similar to ordinary diode. The bar of the cathode is having two small zigzag directional lines in the symbol. Whereas how it looks like physically, that is shown here in red color. And again there is a silver bar normally printed on a cathode that indicates the cathode of the Zener diode. Zener diode can be normally operated in the reverse bias as shown in second figure. See here, anode is connected to the negative terminal and cathode is connected to the positive terminal of the supply through the current limiting resistance. Whereas in forward bias, the Zener diode works as an ordinary diode. And therefore, we are not discussing the operation of Zener diode as a in forward bias region because it is same as another general purpose PN junction. Whereas Zener diodes are normally used as a voltage limiter in reverse breakdown region. The voltage across the Zener diode is normally denoted by a symbol Vz. The current flowing through the Zener diode is denoted by IR or IZ. IR stands for reverse current or Zener current. Let us see the VI characteristic of a Zener diode. If you see these VI characteristics, in a first quadrant, y-axis contains the current through the Zener diode and x-axis contains the forward voltage applied. Up to cut-in voltage, the current through the diode is very small. And after that, if the forward voltage exceeds the cut-in voltage, suddenly the current is increasing exponentially. And it is governed by the Shockley relationship, which is same as ordinary p-n junction. Whereas most important characteristic is the reverse breakdown characteristics. So let us focus on this. Here the x-axis, negative x-axis indicates the Zener reverse voltage applied and negative y-axis indicates the Zener current. You will see here the corner point that is called knee point. When you go on increasing the reverse voltage across the Zener diode up to Vz, the current is very small, that is called reverse leakage current. Whenever applied voltage exceeds the Zener voltage, the current through the Zener will be suddenly increased. And if slight change in the Zener voltage, that gives rise to the operating point of the Zener diode to shift from minimum Zener current to maximum Zener current. And the external resistance connected in series that limits this current. If the external resistance is not connected, then excessive reverse current will damage the Zener diode. And you will see if these characteristics are compared with the ordinary diode, the shape of this reverse characteristic is in the reverse region is more or less a standing line. It indicates that the breakdown voltage is mostly constant as compared to the ordinary diode. And therefore, for all the practical purposes, we will consider that when the Zener operate in the reverse breakdown region, voltage across it will be maintained constant to Vz. In the first figure here, you will see the Zener diode physically how it look like. Various applications of Zener diode. Zener diode can be used as a voltage regulator. It can be used in the over voltage protection circuit, or it can be used in the clipping circuit. Various specifications of the Zener diodes are: the very important specification is the Zener voltage, the Zener current maximum, the minimum Zener current Iz minimum, the power dissipation rating of the Zener diode. Normally the Zener diodes are available in 400 milliwatt, 500 milliwatt, 1 watt, 5 watt and so on. The voltage tolerance is typically, Zener voltage tolerance is typically plus minus 5%. The very important and quite commonly used application of the Zener diode is Zener as a shunt regulator. So that's all friend about the Zener diode.